All right, let's take a look at sample problem C together. So initially, this looks like a lot, but I'm going to tell you in a second, there's a lot of extraneous information. So let's go ahead and dive in. To produce 40 grams of silver chromate, you will need at least 23.4 grams of potassium chromate. Oh, they gave us two different compounds. Let's keep reading. All you have on hand is 5 liters of a 6 molar potassium chromate solution. What volume of the solution is needed to give you the 23.4 grams of potassium chromate needed for the reaction? Okay, so they're just telling you that you're going to work this reaction. This whole to produce 40 grams of silver chromate is actually extra information, right? So it tells us that we need this much potassium chromate, the 23.4 grams. We're not starting with just solid potassium chromate. We're starting with it dissolved in solution, which is another way that we can make things react. And so now this is all just about that. So I have grams of potassium chromate. I know, right, the grams that I need. I currently have 5 liters of a 6 molar solution. What we don't know is how much, right, the liters of that 6 molar solution that we actually need to deliver 23.4 grams of potassium chromate. So the first thing we're going to do, because molarity, right, is moles per liter, we need to convert grams into moles. So we have 23.4 grams of the potassium chromate. We're going to convert that into moles. So going to look at the periodic table, going to add up 2 potassiums, 1 chromium, and 4 oxygens, and that's going to be a nice heavy one. That's 194.2 grams per mole. Okay, so now I take the 23.4 divided by the 194.2, and I get 0.120 moles of the potassium chromate. So what this literally means is this is how many moles I need. Now, you have 5 liters of a 6 molar solution. I may not need all 5 of those liters. So let's see how many we have, or that we're going to need, I should say. So again, you have a 6 molar solution, right? And capital M molarity stands for moles per liter. So instead of putting a capital M, I could put moles per liter so that my units cancel out here in a second. I know the amount of moles I need, so 0.120 moles, but I want to find the volume, right? I want to find liters, so that'll be my unknown this time. So 6 moles per liters times X is equal to 0.120 moles. So to solve for X, I'm going to take 0.120 moles divided by 6 moles per liter. So let's plug that in the calculator. Okay, so 0.12 divided by 6 gives me 0.02. And look at these units. Moles divided by moles per liter means I have 1 over liter, but since we're dividing by 1 over liters, you just have liters left. And sig fig 6.0 is 2 sig figs, so this should be 0.020 liters. All right, so sample problem C is definitely one of the most challenging problems just because there's so much extra information. So again, this is the challenge, not the norm, but if you can do this one, you can probably do any of them.